In this video, I want to review the fundamental theorem of calculus part 1. If you recall, the fundamental theorem of calculus part 2 says that we can use the antiderivative to find the area under the curve. Part 1 establishes the relationship between the antiderivative and the derivative, which leads us actually to the relationship between the integral and the derivative. And what it says is that these two things are inverses of one another. If I take the derivative of an integral, like I have here, the derivative of an integral, I simply get the function. Now I'm going to write it kind of over here, and I'll show you why here in a moment. But it's going to be 3x cubed minus 5x. And the reason it comes out that way is really the same as any inverse. If I plug something into an inverse, or a function, and then do the inverse, I get back what I started with. Well, here I'm integrating a function, and then I'm finding the derivative of it. I get back what I put in. But you will notice that the bound was x, so when I find the antiderivative, if I did that, I would get 3/4 t to the fourth minus 5/2 t squared, evaluated at x and 1. And if I plugged in x and 1, let me put this up here, I'd get 3/4 x to the fourth minus 5/2 x squared. And when I plug in 1, I get 3/4 minus 5/2, or negative 7/4. Well, now I'm told to find the derivative of that, right? It says, okay, integrate it and then find the derivative with respect to x. Well, the derivative of this would be 3x cubed, the derivative of this would be 5x, and the derivative of constant is gone. So all that's happened is I've replaced the variable, right, because I plugged in x, but I just got back what I started with. Now, you learn this in Calc 1, so I'm not going to belabor this too much, and in fact I'm going to do the rest of them very quickly. But it is an important relationship, and we kind of take it for granted that the integral relies on the antiderivative. But it is an important relationship to establish that the antiderivative, or the integral, is the inverse of the derivative. Now in this next example, you'll see the bound is a little bit trickier, and I would just want you to think through this. If I found the antiderivative, which I did up here, and I plugged in 4x squared, like that, and then I found the derivative, well, I would have to break out chain rule. And the reason I'd have to do that is because I placed a function, 4x squared, into my new function. So how you do this in a very shorthand way is you replace the t cubed with the bound, just as we did in the previous one, right? We replaced the t with the bound. But then, because it's a function, we have to use chain rule, multiplying by the derivative of the bound. Now, if you want to think about it this way, go back up to the first one. The derivative of this bound was 1. So you could have said it's 3x cubed minus 5x multiplied by the derivative of the bound. But the derivative of the bound doesn't change anything. Here, we substitute the 4x squared in for both t's, and then multiply by the derivative of the bound. And again, that's chain rule. If you actually did the antiderivative and plugged in 4x squared in place of the t's, and then found the derivative, you would need chain rule because you'd had a function composition. Okay, so let's keep going. We're going to have 3 multiplied by cosine of x cubed minus 5 times cosine of x. And then we multiply by the derivative of cosine, which is negative sine. Okay. Now, this one, you'll notice that the bounds are kind of different in that the variable is on the bottom. Now, I should also mention the reason that we don't really have to worry about this bottom bound in these first ones is because it always was a constant, and the derivative of this constant would always be 0. So whenever we plugged in 1, we would have gotten a constant, and we wouldn't have had to worry about it. Well, I would like that to hold true in this last one, so here's what I'm going to do. I'm going to switch the bounds. When I switch the bounds, I switch the sign of the answer. So easy enough, I mean, I can just plug in that x cubed in place of t, and then I can multiply by the derivative of that x cubed, but I need to remember to make the entire thing negative because I have put an equal like that, because I have changed the order of those bounds. So this is just a review of some of the things that can be asked in the AP exam about the fundamental theorem of calculus, part 1.